Okay, welcome to our new topic on probability. And this screencast is going to deal with just the introduction to that and some of the language around probability, so that when you come to class tomorrow, hopefully you've taken down these notes, you've had a little think about it, and we're going to have a nice discussion about probability and start to then look at solving some problems and doing some tasks around probability. So I think probabilities are quite a difficult thing to define, but I've had a go at it here, and I'd like you to take this definition down, have a think about it, see what you think. Probability for me involves random experiments, experiments, events that have an unknown outcome. Obviously, if they have a known outcome, then there's not a lot for us to do. So we're dealing with things that are uncertain. So, and we're trying to put a number to that, and that number is between 0 and 1. So range of probability lies between 0 and 1. All our outcomes, all our calculations will result in numbers between 0 and 1. 0 being impossible. We're not going to deal with too many things that are impossible, but occasionally we will be asked to find out what's the probability of rolling a 7 on a 6-sided die numbered 1 to 6, for instance. That would be impossible, so that would be a probability of 0, but mostly we're going to be dealing with probabilities between 0 and 1, 1 being certain. There aren't too many certainties in life, and so we won't encounter too many situations where our probability is 1, but it's possible, 0 to 1. Okay, so we're dealing with a huge area of mathematics here, and one that I think ranges in difficulty and understanding from very straightforward right through to some of the most complex mathematics that you can imagine. And some of the most highly paid professionals in industry are those that specialize in probability calculations. So they've moved on from the jelly bean type examples and the tossing the coin, which is the point at which we start. And so let's move on. So there's our range of probability. Introducing a bit more sort of terminology here. This PE, that's probability of event E happening, and that comes down to this fraction here. The probability of an event occurring is the number of possibilities that meet my conditions as my numerator, the number of possibilities that meet the conditions of the question, over the total number of possibilities. Now, this total number of possibilities is also known as our sample space, and that's a term that we're going to use a lot. The sample space. Whenever we talk about sample space, we're talking about what are all the possibilities. If we know what all the possibilities are, if we know how many there are, we can then work out how many of those possibilities we're interested in or meet the conditions of the task, and then we can put it into this fraction, and we have our answer. So, for example, what is the if the event? So let's have a look at an example. Rolling a die, rolling one of these fellas. So we're going to put some dots on it. It's a 6-sided die, and that's our event. So in this event, what are the total number of possibilities? So our sample space is equal to 6. There are 6 outcomes. So we've got 6 all equally likely outcomes. So the probability in this event of rolling a 3 will be equal to the number of possibilities that meet my conditions. There's only one 3 on the die, and there are 6 total possibilities. So that would be 1/6. The probability that it's even. How many now? Well, I've now got a set of numbers that meet the condition that it's even as 2, 4, 6 over the set of numbers, all possible numbers, all possible outcomes. 1, 2, 3, 4, 5, 6. So I've got 3 possibilities on top, and I've got 6 underneath. So the probability it's even is a half. You knew that. But what we're doing here is we're setting it out in the language probability, so that we can take this stuff forward and we can understand each other when we start talking about these things. Okay, so that's a fairly straightforward example. How about we look at setting up a sample space for tossing a coin and rolling a die. Okay, so we look at tossing a coin, so we're flipping a coin and we're rolling a die. So what is my sample space? Well, the sample space, all the possibilities. So we're tossing a coin and rolling a die. What is my sample space? So if we can establish our sample space, then we're halfway there. Okay, well, these are my options. There's a good way, a really simple way, is to make a list. All right, this is option 1, make a list. Make a list of all the options here. All right, we're tossing a coin. Well, that could be a head, and a die. Well, head 1, that's one of the options. And the best thing of doing this is just to start, and you'll get an idea. This is a fairly straightforward example, isn't it? But once you start writing them out, you'll see that there's a pattern to it, and you won't need often to write all the list out. You'll see the pattern of it, and you'll work out from that, because mostly we just want to have a little idea about how many outcomes there are. So we've got 6 plus 6, we've got 12 outcomes here. 12 possible outcomes. Okay, we could make a table. That's another way of looking at our sample space. We could make a table. So in our table, we might have our heads, tails down the vertical, and we could put our rolling a die options across, and there we have each square, each little grid square. That represents one of the outcomes. So this square here represents H6, and this one here represents T2, and you can see there we've got 12 outcomes possible. And once we've got all our outcomes down, once we've got our sample space in front of us, it becomes really straightforward calculating the probability of one of those, or multiple elements of your list or table, working out what the probability of those events are. So for instance, over in our list, we could easily see that the probability that it's a tail and an odd would be, we'd circle those as tail 1, tail 3, tail 5. So there'd be 3 out of those 12 would satisfy our condition, and so the probability of that event occurring would be 3 in 12. So sample space is important. Just undo that. Okay, so the third is to make a tree diagram. Right, these are sort of, there are other perhaps ways of doing so. What I suggest is we don't get bogged down. This is just an idea of how to lay out your work, how to lay out your sample space. But really, the most important thing is to get down on paper your sample space. And if you just, it doesn't need to be anything. It's for your benefit to be able to see the question, see all the possibilities, and go ahead with calculating the probability. Making a tree diagram, this is probably the most popular method. Each branch represents an outcome. So in this case, tossing a coin, head or tail, and then on the back of that, we've got to roll a die. So we've got quite a busy tree here, 1, 2, 3, 4, 5, with all these branches. So at the end of each of these branches, we write down the outcome. So you can see there our 12 outcomes are listed. 12 outcomes are listed, and for instance, this outcome here is T followed by 3. So that outcome there is T3. So we can easily see, once we've got our sample space in front of us, how to calculate the probability for what we're trying to find. Okay, so sample space, brilliant. We've had a chat about that. We've had a chat about the language here of probability, how to calculate the probability of an event. All good. Okay. Last little concept I want to discuss on this on this screencast is empirical probability, which deals with the probability of events that aren't quite so theoretical. So there are events that are dealing with, okay, what is the probability of horse A winning a 12-horse race? Is it 1 in 12, or is it something else? Because not all 12 horses have an equal chance of winning. So we're now talking about events that do not have a defined sample space. That's called empirical probability. So really there are two branches of probability. They're theoretical, we've looked at briefly here, when you're able to list a sample space and it's all there. You can definitively say that these are all the possible outcomes. That's what we might call theoretical probability. Empirical probability is dealing with experiments, dealing with the probability where the sample space is not defined. We have to almost create our own sample space by taking a survey or doing an experiment and doing it over and over and over again. So empirical probability is based on experiments and calculations based on the results of surveys or data collection rather than sample space, if that makes sense. Okay, so what is the probability that the Sydney Swans will win this weekend? Well, it's highly probable, given that they're a very, very good side. But we can't say that the sample space is 20 and they've got 15 chances of that 20 winning. They're not. It's not like rolling a 20-sided die. This is an example of empirical probability. How do we calculate the probability? Well, we'd have to look at the form. We'd have to look at how they've performed in the last 10 games. Perhaps we look at how they performed over the last 10 years at that venue in this with these weather conditions under this coach. There are so many, with this group of umpires, there are so many variables that go into the calculation of that probability, which is made by bookmakers when they're setting odds. So empirical probability, fascinating area. What's the probability that the next car that drives down your street is coloured green? You could guess that it's quite low. You could guess it's quite high. You'd be better off taking a survey of 10, 50, 100 cars, and the more the better, and working the probability out from that data. So this is empirical probability, a fascinating area. We're going to spend a bit more time talking about it. The last thing I want to discuss before I close are complementary events. Complementary events. So complementary events. Sorry, let's just get this down properly. The complement of A is A dash, which means not A. So the complement of A is everything but A, and you denote the complement of A by A dash. So in an event, the probability of A plus the probability of A dash will equal to 1. So, sorry, that was a plus there. The probability of A plus the probability of complement of A will equal 1. So that is all I wanted to say on that, really. The complement of an event is just everything else. So if we're talking about rolling a die, the complement of the outcome 2 is 1, 3, 4, 5, 6. And that closes. I'll see you in class tomorrow. Hope you've enjoyed the screencast.